Okay, guys, so looking at these examples, we're going to determine if there's enough information to figure out if the triangles are similar. If yes, we're going to write a similarity statement, the postulates for y, and then if there's a missing value to solve for, we will do that as well. Right? So looking at this first one, we are going to have to look, we're given information about angles. Let's recall we can use the angle similarity postulate, the side similarity postulate, as well as the side postulate. So we're using one of these three to prove if two triangles are similar. Looking at number one, we are given angles, so we have to use angle-angle theorem, if anything. Okay? We don't have any information about sides to figure out if they're proportional. Okay? So we can look, we have angle 42 and angle 42. So one angle is congruent in the triangles. Okay? Then we have 65 degrees and 73 degrees. 65 and 73 aren't equal, but we can now say we can figure out angle A and angle P to double check. So if we do 180 minus 42 minus 65, we are actually going to get 73 degrees. And in the smaller triangle, if we did 180 minus 42 minus 73, we would get 65 degrees. So angle A equals 73 degrees. So that means angle A and angle Q are congruent. So by the angle-angle postulate, we can say that these two triangles are similar. So our similarity statement can be triangle CAB is similar to triangle. Now I have to go to corresponding sides. So CAB, 42, 73, 65 degrees. So I have to follow that same order. So I'm going to do RQP as my last triangle. That tells us that angle C and angle R are corresponding and congruent angles. Angle A and angle Q are the corresponding and congruent angles, and then angle B and angle P as well. And this is true by the angle-angle postulate. Looking at example 2, we have that these two sides are congruent. And then, so this might be 10, this might be 10, and then these sides are congruent. So it could be 7 and 7. It could be other numbers as well. We don't know the values, okay? We just know that these two sides are congruent and these two sides are congruent to each other. So we have two sides. We don't know any information about the angle in between, so we can't use side, angle, side. We don't have any information about any angles, so we can't use angle, angle. Side, 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 we have two, but we don't know anything about these third sides. So there is not enough information to prove similarity. Looking at example 3, we know information about these sides. We don't know anything about the angles. So we need to see if side, side, side will work. Okay? So we know that this side, side AC, side CB, and AB are all congruent to each other. So we have one equilateral triangle. And then FH, HG, and FG are all the same size as well. So for example, this might be side lengths of 5, and this might be side lengths of 2. It could also be 320. We have no idea what the side values are, but if we take this side, so if we take HG and put it over CB, because they're going to be the same numbers, or there'll be some ratio, we can check it with FG and AB. Okay? These HG and FG are going to be the same numbers since they're congruent or equal, and CB and AB will be the same numbers because they're congruent. So we're going to have two equal fractions because the side values will be equal. Okay? So like I said, if this was 2 and this was 5 and this was 2 and this was 5, 2 and 5, this might look something like 2 over 5 equals 2 over 5. So our sides will be proportional, so they're similar. So triangle ABC is going to be similar to triangle FGH by side, side, side. In example 4, we are given angles, but we don't know what those letters mean. So we can't figure anything out with angles. We are given all 3 sides, so let's see if side, side, side is gonna work. So I'm gonna take my smallest side, 9, and divide it by my smallest side of the other triangle, 12. Find my largest one, so 21 and 28. And then the last one, 15 over 20. Please make sure if you do the small triangle as the numerator, each side of the small triangle is on top of the fraction, and each side of the big triangle is in the bottom, or the denominator. All of these are going to simplify, so we have 3/4, again 3/4, and again 3/4. So all of the proportions simplify to the same thing. All of these fractions are equal or equivalent. So yes, triangle ABC is going to be similar to triangle, so I did small to medium, so I need to do the same thing here. So UST is my second triangle, and this is by side, side, side. For number 5, we are going to look, we are given 2 sides and an angle included, right? And then 2 sides and their included angles. So we're going to have to use side, angle, side to prove this. So again, we're going to find our small sides, so 20 and 5. Ooh, they're flipped. How many of us thought it was going to go to 6? Be careful with that. And then we have our larger side and our larger side. So 5 over 20 is going to simplify to 1/4. 6 over 24 simplifies to 1/4 as well. These angles are indicated as congruent. So triangle ABC is going to be similar to triangle QRP by side, angle, side. And our last example, so we have a right angle in both of these, which means this is 90 degrees. Then we have a 53-degree angle. Let's see, that means Z is going to equal 37 degrees. Sorry, we're getting cut off on there. So that means Z is 37 degrees. This other angle across from it is also 37. So yes, triangle ABC is similar to triangle ACD by angle, angle. Okay. Now guys, y'all are gonna go and practice with some similarity postulates to see how you feel about these.